Hi there, I'm Clemolo. Today we're going to have a look at how fast or mostly how slow humans are compared to embedded systems. I feel like those are good to have an idea of a feeling of how fast a system can be and so how much calculation you can make while a human doesn't realize it yet. Another way of thinking about it is like how much time your microcontroller can sleep even without the human noticing it. If you manage to go to sleep during 9 milliseconds when you got only 1 millisecond of work for interacting with the human, well, you've saved 90% battery. So knowing how fast the human react and what is instantaneous for them is actually very important in our case. Today we're going to do two tests. First of all, we're going to see how fast humans react. That's going to be set up as the microcontroller turn on some LEDs. The human need to press a button to turn them off. The goal is to be as fast as possible. Then we're going to do another test where with the human is going to press a button and the LED are going to turn on with some delay. The question is going to be below which threshold of delay does the human notice or does not notice that there is a delay at all. The first test is going to be to see how fast humans react, and that include seeing, processing and sending the command through the muscles. And then the other test is just going to be perceiving. I press the button and how fast I see the LED turning on. Let's see that. Here in our software we did something extremely dumb when it comes to the randomness, because humans are not very good at measuring random. So we just got a list of random delays that we're going to be using in our case. The idea is that after that delay, we turn on the LED and we measure how long the human took to press the button. And we display it in the serial command, and that's it. Let's see how I do and how my cameraman does at that test. So there we got the test running. The LED are on. They've been on for a while, so I'm going to press button 1 to turn them off. And that's going to display in the screen that I was 30 seconds late, of course. Now I wait for the LED to turn on randomly. Oh, and there I was 367 milliseconds late. Oh, another one. 300 milliseconds. 255, getting better. One. 312. Those are the numbers that I can get more or less reliably for me. There, Paying, you're gonna do the same. The LED is gonna turn off. You need to press the button when the LED turn on. Like you need to go as fast as possible to press the button when the LED turn on. Yes.
And then what do I do again?
And that's it. You just wait for the LED to turn on and you press the button. When it turns on, it's random. Yeah, there you're a bit slow. You should have pressed. As fast as possible. So there, the way you did, you are at a bit more. So you did around 300 and 400. Me, I was around 300, sometimes going a little bit lower than 300 milliseconds of delay. So a third of a second reaction time.
I did way more than
A little bit. So there, you get a order of idea, like when you prompt the user to do something, you can expect at best around 300 milliseconds before the human is going to be able to react in any way, shape or form. Those 300 milliseconds are hugely long for a microcontroller to wait. So don't hesitate to go to sleep during that time, for example, to save battery, or do other processing if that's available. So in that second example, in that second test, we're just going to try to see how fast humans consider as being instantaneous. The idea is that we press that button and the LED are going to turn on after some delay. We got those two buttons below to increase or decrease that delay, and we'll see what humans consider as instantaneous and what is not instantaneous. So I'm going to do it. So there we can turn off the button, turn on the button. There we got a delay of 10 milliseconds. That's very short for me. So if I increase that in something a bit more obvious, something that we're going to be able to see on the camera, example around 400 milliseconds, I press and then it turns on. If you do it again, I press and it turns on. So there is an obvious delay at 400 milliseconds. The question is that if I go down, when do I start noticing? I still notice it widely. I'm looking at it to have an order of ID. Still notice it. We're getting lower. There got trouble. I feel like there is a sweet spot for me. That time, I feel it like press and it turns on. It's exactly 100 milliseconds as it turns out. 100 milliseconds. There, Pauline, you're gonna do the same test. I'm gonna reset up for you. So you saw, press that button to turn on, and you tell me, is it instantaneous or not? Like, oh no, there it takes time. And it's there to turn it back off. So there, and you can, press that one, and you see the LED turning on. Did it turn on immediately, or did it wait a little bit?
Sure.
Yes, then you can press the other button, so yes, that's the reset one. And you do it again, and you see, did it take time or not?
Yes, it takes a little bit time.
Okay, so then you can press the bottom one to reduce the delay. And so there it's going to take less time. So you can press multiple times, and then you need to reset to turn it back off. So yeah. Yes, so you can press again to get lower. You can press a few times. Yes, and there you try again to see. This one is immediately or not?
Yeah, so you're going to do it.
Yes, so you're not at the... Yeah, this one, is it immediately or not?
A little bit slower.
So can you say, does it look immediately or not? Yeah.
I think so.
This one is immediately? So that seems to be your limit at 60 milliseconds. So better than me.
What do you mean?
You see the difference down to 60 milliseconds. For me, it's like 100 milliseconds around. So there you have it, an idea of how fast and how slow actually humans perceive the world and how slow they react to the world. From the numbers just on two people here, we can see that when pressing a button, the microcontroller reacting in less than, in one case 100 milliseconds, in another case less than 60 milliseconds, the human perceives that as being instantaneous, no delay at all, which, as it turns out, even 60 milliseconds, the lowest numbers here, that's a lot of time for the microcontroller. You got plenty of time to go to sleep, for example. And when it comes to actually reacting the other way around, the microcontroller prompting the human with something and the human mechanically reacting to it, that number tends to explode to more than 300 milliseconds at best when it comes to a very simple interaction like just pressing a button while being ready and waiting for it. That's in the best condition. There again, plenty of time for your microcontroller to go to sleep to save battery or to do some communication stuff or some calculations or other stuff. I hope this video helps you get those numbers in mind and prevent you from having to spend the time doing those tests yourself. See you! The bear. Boo, I'm microcontroller bear. Nya, nya, nya. No? Yes, he eats the microcontrollers. Nya, 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 nya. But he got lithium poisoning. That's why he's made of wood now.
What is his name?
His name was Bernard. Yeah, was. He's dead now because of lithium. Be careful with lithium, kids. Is it a lithium one? Yes, it is a lithium one.